Okay, good afternoon and welcome to the 7th session in the Spring 2019 SunoikisisDC Digital Classics program. This session is the second of two sessions related to tree banking. This session is on using Treebanked Corpora, universal dependencies, and will be presented by Marco Passarotti from Milan and Timo Korkiakangas from Helsinki. And I believe Marco will start us off with some introductory material now. So I'll hand over to you now.
Good afternoon.
Hi.
I will start. So I will provide you with, first of all, a very brief introduction to what is a tree bank, and then we will talk about the two different seeds that you can use to plant trees, syntactic trees, and then I will move to the very core of my part of this lesson, that is about the universal dependencies. So I will go very quickly in this first part because I give for granted that you know what a tree bank is. A tree bank is usually defined as a syntactically annotated corpus. So a corpus annotated with some metadata, linguistic metadata that include lemmatization, disambiguated in context, morphological features, also disambiguated like gender, mood, tense, person, number, and of course, syntactic analysis. And syntactic analysis will be the core of my lesson, and you can use two different seeds for the syntactic trees. And this is the reason why we talk about tree banks, because they are really banks of syntactic trees. And these seeds are two different grammars. First of all, on one side, there are the so-called phrase structure grammars, called also constituency grammars. And in a PSG tree, you can find nodes that are filled with words, parts of speech like noun, verb, adjective, and so on, phrases like prepositional phrases, verb phrase, and so on, and star symbols. The basic idea here is categorization. So you start from the leaves of the trees, where there are the most specific elements that are words, and as long as you move toward to the top of the tree, you go through nouns, so names of parts of speech, names of phrases like noun phrases, until the root of the tree, that is the sentence. You cannot see my slides? Oh.
No, you're not screen sharing it. Sorry.
Sure. Just a moment here. Screen sharing this way. Here it is. Okay, now?
That's great.
Okay, sorry, my fault. So on the other side, you can use dependency grammars to design trees. In a dependency grammar tree, the nodes of the tree are filled only with words, those that are called terminals in phrase structure grammars. And these lexical nodes are connected via binary and hierarchical relations called dependencies. In a dependency grammar tree, there are no horizontal relations or cycles, and at least in principle, there is no marking of the word order, which made dependency grammars pretty suitable for describing the syntax of free word order languages, so languages with rich morphology, like Dutch with the Alpino Treebank, Italian originally with the Turin University Treebank, Czech with the Prague Dependency Treebank, and of course Latin with the Index Domesticus Treebank, the Latin Dependency Treebank, and the Proreal Treebanks. So, to give you just a very simple example, this is the PSG representation, so constituency grammar representation of Audentes Fortuna Juvat in Latin. And as you can see here, as long as you move along the tree from the terminal nodes, so from the leaves to the root of the tree, you move from very specific elements, the words, audentes, fortuna, and juvat, and then to parts of speech, phrases, until the root of the tree. You see here that there are two overlappings. This is not really a problem in itself, but it might become a problem when you want to build a dependency parser, which is a tool that produces automatically syntactic trees for your input sentences. So, what about the dependency grammar tree for audentes, fortuna, juvat? It's very simple. You have three words, audentes, fortuna, and juvat, and so you have three nodes, 1, 2, and 3. As I said, the word order in principle is not marked, so in principle these two trees are completely the same because the word order is not marked. What is important is that in dependency grammar, predicates are more important than their complements. Predicates are the heads or of the sentences or the clauses of a sentence. So here you have that the predicate juvat has two complements, audentes and fortuna, and these complements are marked with dependency relations labels like SB, subject, and OBJ, object. So audentes is the object of juvat, and fortuna is the subject of juvat. It's pretty simple. Okay, now that we know what a treebank is, what dependency means in this context, let's move to universal dependencies. So universal dependencies, you can find all information about universal dependencies at this URL. It's defined as a cross-linguistically consistent treebank annotation for many languages. You see 129 treebanks available for 76 languages in the current version of universal dependencies, which is version 2.3. There are 2 regular releases of universal dependencies every year, usually on 15 May and 15 November. And basically, universal dependencies is a big collection of treebanks of many different languages, all annotated following the same annotation style. This maybe can seem trivial to you, but it's not, because until 5-6 years ago, universal dependencies was not there, and we had several treebanks for different languages which were not annotated the same way. And this was a problem. Why universal dependencies was needed, and it's needed? Because in the community, there is an increasing interest in multilingual natural language processing. Multilingual natural language processing means processing automatically textual data, linguistic data for different languages. So what we need is to evaluate how the different tools work on different languages. And most of all, we need to make cross-lingual learning to support low resources languages. Well, this means that there are some languages that have a few number of linguistic resources. Imagine a language that has no treebanks or a very small one. So we can train a natural language processing tool on other data, I mean data coming from data for other languages, and then we can in some way delexicalize this tool and apply this tool on this new language for which you have just a limited number of resources. Well, the accuracy rates won't be the best rates that you can have, but at least it's a starting point. Well, there was an increasing awareness of some methodological problems. First, current natural language processing relies heavily on annotation. You see, I use the word to train. In 2019, most of the NLP tools are stochastic tools, and you need a training set to train a trained model of these stochastic tools. So we really rely on the annotation provided by Untitled Corpora to train well-performing natural language processing tools. The problem is that we had actually different annotation schemes for different languages. So we had the need to find one common annotation scheme for different languages. So you see an example here. A cat chases rats and mice. Well, this sentence is taken from an English tree bank, in particular the Stanford type dependencies. The same sentence in Swedish, I don't try to pronounce Swedish, sorry, and it's taken from the Danish dependency tree bank, and the same sentence in Danish is taken from the Swedish tree bank, and the same sentence in Danish is taken from the Danish dependency tree bank. The three sentences are completely the same. So a cat chases rats and mice. The syntactic structure is completely the same in the three languages, in the three examples, but you can see that the dependency relations and the names, the very names of the dependency relations are different. So it's very difficult to make some cross-lingual evaluation of NLP tools when you deal with different annotation styles. And even when you use the same dependency relations, like in this case, direct object or conjunct, which means conjunct, they are sometimes applied differently. For instance, you can see here that conjunct connects the coordinating conjunction og with the second conjunct, while in the English tree bank, conjunct depends on the first of the conjuncts. So this was the problem. And why is this a problem? Because this makes it hard to compare empirical results across languages. It's a dream for me as a tree banker that today you can run the same query on different languages. In principle, you can run the same query on all the 129 tree banks available in Universal Dependencies 2.3. Believe me, it's a tree. I'm in this area since 2005, and I couldn't imagine something like this. Well, I could dream about something like this, but it's not obvious. In the same way, it was hard to usefully do cross-lingual structure transfer, so you can understand how syntax varies from one language to another. And it's hard to evaluate cross-lingual learning, what I mentioned some minutes ago, when I train a tool on one language and then I apply this on another language. And it's hard to build and maintain systems that want to be multilingual, be applicable on different languages. And of course, and this may be interesting for the theoretical linguists here, it's hard to make comparative linguistic studies, because you couldn't run the same query on different languages. And of course, it's hard to validate a linguistic typology, which means that there are some groups of languages that show some common properties that can be evaluated now using universal dependencies. And of course, this is more for the NLP people here. It's hard to make progress towards a universal parser. Actually, I do not believe that we can really do it, but let's hope for this. So the solution is to have one common annotation style, a cross-linguistically consistent grammatical annotation, which is not built from scratch, but it's built on common usage and existing de facto standards, because across the years, scholars have developed several annotation styles, tag sets that have become, through the years, standards or reference standards, and we use that. And the language-specific schemas, so those annotation styles that are used for one specific language are not completely left out, but they are not replaced, but they are complemented in universal dependencies. And universal dependencies is an open community effort, which means that there is no one defined and funded project, but people are free to contribute to universal dependencies with their data, with their contribution, with their idea, also modifying the annotation guidelines of proposing changes to the guidelines. This is important because I remember that when universal dependency started, people were a bit skeptical to provide their data. Instead, today, everyone who built a Treebank wants to provide universal dependencies with his or her Treebank. So the universal dependencies philosophy is based on merging existing initiatives to build consistent language resources. Across the years, several of these initiatives were started. I just mentioned very briefly here the 4 that were used while building the universal dependency style. One is the so-called interset interlingua for morphosyntactic subset, which was a tool developed in Prague for converting between subsets of multiple languages. Well, this is a problem because you can use different labels for the same thing in different languages or in different tree banks, and you need a tool to make a conversion between these subsets. The second initiative was Google Universal Part-of-Speech Tags, which was a tagset built for this called shared task in 2007. And then the Stanford Dependencies, which from 2005 were the de facto standard for dependency analysis of English. And finally, the Google Dependency Scheme, which was really the first attempt to combine the Stanford dependencies and the Google Universal Part-of-Speech Tags. So the syntactic analysis and the lemmatization part-of-speech tagging, morphological analysis, towards a universal annotation scheme, which became the Universal Dependency Treebank in 2013. So basically, universal dependencies wants to replace all these standards, all these initiatives, and to exploit at best what they developed with a single coherent standard that today is universal dependencies. So there are 3 basic design principles in universal dependencies. One is dependency. So we use dependency grammar because it is widely used in practical NLP systems, and today is available in several tree banks for different languages. Since the end of the 90s, there has been a kind of dependency turn in computational linguistics and in particular in tree banking. I perfectly remember that till some years ago, there were several papers about the conversion of a constituency tree bank into a dependency tree bank, because the first tree banks were originally built on phrase structure grammars. But in the last 15 years, dependency grammars have become really the de facto standard for building tree banks. Second, lexicalism. Basic annotation units are words, syntactic words. So we split off clitics, like in Spanish, dámelo, 3 tokens, da, me lo, which means 3 notes in the tree, and contractions are done, like in this French example. And words have morphological properties, so this is morphological annotation, like gender, mood, tense, and so on. And words enter into syntactic relations, as we will see in a while. And then another important aspect is the recoverability, which means that you must always be able to make a mapping from the input text toward the segmentation. So if you segment dámelo into 3 words, into 3 tokens that become 3 nodes in the tree, da, me lo, you must always be able to get back to the source, to the original text. And this is recoverability. Okay, let's see morphological annotation. It's very simple. You see that for each word form here, this is the sentence in French. For each word form, there is the lemma. and then there is a part-to-speech tag. These tags come from this universal part-to-speech tag set, which is used for all the tree banks in universal dependencies. And then there are the morphological features, so gender, number, mood, tense, person, and so on. And then there is the really exciting part, that is syntactic annotation. Unfortunately, here I do not have time to enter the details of syntactic annotation in universal dependencies, but what I want to tell you is the way that you usually have to follow to build a good universal dependencies tree. First of all, find the content words and connect the content words by dependency relations. So in this sentence, the cat could have chased all the dogs down the street. We find 4 content words: cat, chased, dogs, and street. And what you do is to start to build the basic dependencies in this your first universal dependencies tree. And remember that a dependency grammar is a predicate-centered grammar. So the basic idea is always start from the verb. The verb here is chased, and then find its complementations. So chased as nominal subject cat, its object is dogs, and then there is an oblique complement, which is street, down the street. And now we will see how to treat down and there. Well, things are not actually always so easy, but let's start from here. So then, once you have connected by dependencies the content words, let's move to function words. And function words attach to the content word they modify. So here it is. Cat is modified by the as a determiner. Chased is modified by 2 auxiliary, could and have. Dogs is modified by 2 determiners, all and the. And street is modified by a determiner, the, and an at position, which is down, which is assigned the dependency relation case. And finally, punctuation attached to the head of the sentence or the phrase or the clause. So in this case, the dot is dependent via the dependency relation punctuation on the root of the tree, which is the verb chased. Last slide. When you download the universal dependencies tree banks, you will download the data in this format, which is called conl.u. U stands for universal and conl for Conference on Natural Language Learning. It is a tab-separated value format where in the different columns you find, first of all, the ID of the token. So this is the first token of the sentence, this is the second, this is the third, this is the fourth. Then there is the word form, they buy and sell books, dot. So this is the sentence, they buy and sell books. Then there is the lemma. This is English, so lemmatization is not so exciting, but for books, you can see that the lemma is book. Then there is the part of speech, the coarse grain part of speech and the fine grain part of speech, so conjunction. While this is coordinating conjunction, there is also the subordinating conjunction. Then there are the morphological feature, gender, mood, tense, and so on. And then this means that by is the root of the tree. It depends on the number 0, while all the other tokens, all the other nodes in the tree depend on the nodes which is assigned ID number 2. So this means that they and sell books and the final dot all depend on the node for the number 2, which is the node for buy. And then you have the dependency relations, nominal subject, conjunct, direct object, and so on. I will not enter the details here. So the treatment of coordinating conjunctions is slightly different in Universal Dependencies version 2. I do not enter the details. I just want to tell you that Universal Dependencies is a lively project. So things do change in time. There is a version 1 and a version 2, and guidelines are different. And here there is a big mistake. You see that you cannot be the father of yourself. So the token number 4 here depends on token number 4, which is a cycle, and it's not right. So this is a mistake. And that's it. I'll leave the stage to Timo.
Okay, are you hearing me now?
Yep, we are.
Okay, wonderful. Hello, I'm Timo. Greetings from Helsinki. So I will go on with the same theme that Marco introduced here, so tree banking, but my focus will be on querying tree banks. So I'll switch to my slides now. Well, now, fine. So, my purpose is to, my intention is to show you an example of a hypothetical workflow of querying a tree bank in order to extract information that you can then use to answer a research question. I'm sure that 2 weeks ago on the introduction to Treebank lesson, you noticed that annotating tree banks is really nice. However, besides entertaining, the central purpose of tree banking is to make quantitative research possible. And that's why it's also necessary to learn to query tree banks, not only to build them. So my intention is now to present something relatively complicated, but also to motivate why it is so and why this kind of query is done. So querying means that we compile a query formalism in a query language and run it on a tree bank. This can be done in specific programs that support our query language. Of course, we need first to know that what we are looking for. I mean, we must have a research question. You have perhaps already read or you are going to read Berta González Saavedra's and Marco Passarotti's paper on how characters act in Sallust's Bellum Catiline. I think that's a wonderful example about how tree banking can be used for linguistic philological purposes. So I'll present you one practical example of querying Latin dependency tree banks that come from the ancient Greek and Latin dependency tree bank. You have already seen this page 2 weeks ago. This tree bank version is not UD, but simple XML that is called Ancient Language Dependency Tree Bank Format, ALDT. The bird elements contain a set of attributes that carry linguistic information, like we have seen 2 weeks ago. But now it's time to invent a research question. So actually, it was a couple of weeks ago when I was reading some excerpts from Caesar's De Bello Gallico after a long while. My eye was soon caught by some discontinuous noun phrases. I have learned that discontinuous phrases are a characteristic of poetry. But now I found some blatant ones in Caesar's Gallic Wars, which is prose. Discontinuous means here hyperbaton, a construction where the phrase is made discontinuous by an insertion of other words. For example, in this Caesar sentence, he permanserunt aquae dies cum plures, the modifier he is detached from its head, aquae, by the predicate permanserunt. So the noun phrase he aquae is discontinuous. There are, of course, several types of hyperbaton, but for the sake of clarity, we only concentrate on this he aquae type. In this type, the head noun has a preposed modifier, typically an adjective or adjectival pronoun, which is in the same case as the head noun. And there is one or more inserted words in between, and those words are not modifiers of the head noun. So our research question could be, do Latin prose and poetry differ in their use of hyperbaton? And that could be more precisely formulated like, is the relative frequency of discontinuous noun phrases with the same case pre-modifier and non-modifier intervener higher in either genre, prose or poetry? I think this is a relatively well-defined question because it can be easily operationalized, which means that the relevant features can be measured conveniently and reliably. I think this question is also theoretically motivated because we know that the language of poetry makes use of a set of linguistic devices to reach poetic elevation. In fact, traditional scholarship has discussed the language of Latin poetry and prose from various angles. However, those traditional studies, are mostly qualitative by nature. What we are going to do now is to use Treebanks to contribute to this question quantitatively on a certain data set that we have to choose next. You have already tried your hand at fables with the exercises of the introduction to tree banking lesson. So let's look at the Latin dependency tree bank of Feeder's fables. The tree bank contains the books 1 to 3. And as for prose, we choose, of course, Caesar. Unfortunately, there is quite a little Caesar annotated, only 71 sentences. And they come from the second book of the Gallic Wars. In comparison, Feeder's has 583 sentences, so our corpora are not well balanced in terms of size. However, Caesar's sentences are much longer, so the disproportion is not that bad on the word level. Well, I have downloaded the annotated Caesar and Feeder's Treebank files on my laptop, and as I said, they are in the ALDT format. Now, I'll use the same query language that is often used with ALDT format, the PML tree query, which operates on the PML format of XML and runs, for example, in thread Treebank editor. That's why I have converted the Treebank files into PML format by applying an XSLT style sheet. That may sound scary, but it's actually quite easy. The style sheet is a kind of template, a template that transforms one type of XML into another. On this slide, you can compare ALDT annotation with PML annotation. You notice perhaps that that I don't utilize the same version of ALDT or PML as Maria and Paulina did on their lesson. This particular ALDT version is, I think it's perhaps more classicist friendly because the attribute names and values are traditional grammatical terms like person, number, and tense. It goes with an ALDT style schema file that is uploaded to the thread query program. And this is finally our query environment, the thread Treebank editor with PMLTQ extension. So first you need to install thread, and then you need to download the PMLTQ extension from a thread menu. I won't show you that because it would take too much time. Anyway, you'll get a link to the PML3 query tutorial that contains instructions on how to install thread, as well as other information necessary for running PMLTQ. The thread interface has a query window on the left, where the query can be designed graphically, and a tree window on the right, where the syntactic trees of tree banks are visualized and browsed. And at the top, there are lots of buttons for designing and running queries and browsing results. But before we write the query to extract all the occurrences of hyperbutton, we must have a glimpse at the query elements. So you again notice that the attribute names are different than those that were shown you on Maria's and Paulina's lesson. In dependency grammar, all the constituents of a clause are dependent on the predicate verb, as has been repeated several times. It has been decided that the predicate verb is dependent on the root, and this root corresponds to the sentence element in the XML, and it's marked here with the ALDT sentence node. It's always the highest node in each syntax tree. Thus, all word nodes are direct or indirect descendants of the sentence root node. Well, our query window is still empty. Let's create an ALDT sentence node in the query window by hitting Add Node key top right. And then we create an ALDT word node by hitting the same key and by choosing the relation between the nodes. This relation is always chosen in this small box that appears in the middle of the screen. We select descendant, so we make sure we have a path to the sentence root from whatever word the query returns us. Now, this red alt ALDT word node is the head noun of our discontinuous hyperbutton construction. Let's add the other word, the modifier, like he in he akve. In this case, the relation between the head noun and the modifier is that of a child, an immediately dependent relation. This is because in dependency grammar, a modifier is dependent on its head. In a hyperbutton, there is, by definition, an intervening word between head and modifier. So we must add that word as well. It may look counterintuitive, but I insert that word below the modifier and select order follows as its relation. This means that in the actual text, the lowest node comes after the higher node. like permanserunt comes after he in he permanserut aquae. The intervening word also comes before the head noun, just as permanserunt comes before aquae. Well, at this point, it's useful to name the nodes. That's done by clicking each node and the node naming key above. I decided to name the nodes in a rather dull way, in alphabetical order, so that the sentence node gets $+a, and so on. Well, actually, I forgot to say that we must necessarily mark the order relation between the head noun and the intervening word as well. As you see, I created an additional order follows relation between those nodes, so that the order follows arrow points from the intervener node to the head noun node. It's much easier to mark these relations when we have name labels on those nodes. Well, yeah, we still had one more condition, and that was that the intervening word mustn't be a modifier of the head noun. That's why we add a relation that negates the possibility that the intervening word D is a directly dependent child node of the head word node B. So the child row leads from B to D, and it's negated, as is shown by the small, this very small cross over the arrow. I now also open the query editor window here in the middle, so we can see in text form everything we have built graphically. Actually, I usually prefer writing all the queries in this text editor. Here you see a hierarchical structure of our query. Nodes are dependent on each other and connected by relations. Please note that the negated query node is marked with an exclamation mark in front of it in the query editor. So the idea of all this is to turn the linguistic construction that we are looking for in the Treebank into a kind of a stencil. The program then goes through the whole Treebank and returns all those trees that contain that specific stencil pattern. Good. So far, we have created the nodes and the relations between them. We still must define the attributes we want to assign to the nodes. That's best done in the query editor. Most importantly, we must state that the syntactic relation of the modifier really is modifier or attribute, which is marked with ATR. Then we want to define the parts of speech. We decided to examine constructions with noun head only, so we write that the part of speech, or POS, of the head node is noun. The modifier can be either adjective, adjectival pronoun, or noun, and we write it in this way, adding the alternatives between curly brackets. Finally, we also state that the case form of the modifier must be the same as the case of the head noun. We also want to get an easily readable output, so we add a filter line that gives us the sentence identifier of the sentence in which the hyperbutton is found. I mean this subdoc, as well as the word forms of the modifier, the intervening word, and the head, all in this order. Distinct means that we only want each hit once. Now let's hit the query key, we get a list of 233 occurrences of hyperbutton. However, as soon as we start scrolling the list, we notice that some of the occurrences are not actually hyperbuttons. This is because the conjunction que as well as punctuation marks are annotated as independent tokens in the tree banks. Well, it's in fact very typical that you must fine-tune your query several times before it works well. So we modify our query so that the intervening word can't be que or punctuation. Now, the results look better, but there is still one name that is not hyperbutton, Titurium sabinum legatum. It's easiest to remove it manually, I think. Anyway, we see that our query lists all distinctive occurrences, but given that there may be more than just one intervening word, some hyperbuttons are stretched over several lines. For example, at the beginning, crebri ad eum rumores is found on 2 lines because the modifier crebri and the rumores are separated by a 2-word prepositional phrase ad eum. Well, we can remove the intervening word from the output filter, and in that way we get a 2-column list of 129 hyperbuttons. If we take out Titurium sabinum legatum, we get these distributions. So the Caesar tree bank only has 9 occurrences of hyperbutton, while Feeders has 119. Because the Feeders tree bank is much larger than Caesar, we have to look at the percentages instead of absolute values, obviously. The hyperbutton percentage of Caesar is 0.6, while that of Feeders is 1.8. And this difference is statistically significant as the chi-squared test shows. So hyperbutton is 3 times more frequent in Feeders' poetical Latin than in Caesar's prose. As far as we dare to generalize based on this rather small data set, the results seem to confirm my initial superficial assumption that hyperbutton is clearly more typical of poetry than of prose. We can answer affirmatively our research question, which was, do Latin prose and poetry differ in their use of hyperbutton? Yes, they do. However, there are hyperbuttons even in Caesar's prose, and I would say some of them are quite striking. In fact, hyperbuttons are not the privilege of poetical language, but they occur in classical and later Latin prose too. Actually, they are nowadays considered an inherent feature of Latin language with a specific stylistic distribution, which is not yet well studied. So I think it's only natural that hyperbutton is favored by poetry, where it is convenient to modify the usual word order to obey the meter. If you want to read more about hyperbutton in Latin, I suggest an article of Jonathan Powell's that you see cited here. Of course, we must be very careful with the results of this narrow study. If we wish to draw really convincing conclusions on the use of hyperbutton in Latin, we should conduct a much more detailed study. Do remember that we only looked for one single type of hyperbutton. We should include more, if not all, types of hyperbutton. We could also examine if certain genres or authors use hyperbaton differently. If the construction is more frequent with certain case forms, with a certain restricted set of lexical items in a certain syntactic function, in direct or indirect speech in certain metric positions, etc. So what did we learn from this small experiment? I wanted to show you an example of what tree banks are good for. I could have shown you something simpler, like counting the percentages of all parts of speech or of all syntactic relation tags for prose and poetry. And that might have been interesting. However, that's something you can do with simpler tools, like with the find command in any text editor. So my intention was to demonstrate how complicated questions you can ask when you have a syntactically annotated tree bank and when you use a powerful query language like PMLTQ. And I think our joint lecture was also a reminder that there are several different types of tree banks and query languages still. Although standardization is going on, anyone who uses tree banks still has to tackle lots of different annotation conventions and tools. Okay, I think that was it. I hope my talk wasn't too frightening. This is all perfectly doable. You will find the links to the necessary resources on this slide and on the course GitHub. And in the meanwhile, I also invite you to play with the PMLTQ web client online here. And that was it.
Lovely, thank you very much, Timo, and thanks, Marco, both of you for. I think it's very useful. I don't think this was scary at all. I think it was a really useful illustration of the sort of thing you can do with tree banks that you can gain by querying. I think if we had gone into that thinking that we all needed to be able to do what you just showed us how to do, that might have been a bit scary. But I think people who are very keen on this will be able to follow that and follow the links you've given and do that workflow. So I think that was really useful on both counts. So thank you. I have a sort of preliminary question, which is still sort of forming itself in my mind, but it's precisely about your final point about standards and what Marco was talking about quite a lot with the universal dependencies. And if I may be a little bit cheeky and preface my question with an XKCD comic, the question is not exactly, is universal dependencies really creating a single standard for this, but it's more, the question I guess is more, well, so it's in several parts. You showed an example of converting from one Treebank XML format to another to make it more easy to query. And Marco, I think you mentioned that you can convert between different Treebank standards and universal dependencies standard. And so the first part of my question is, are those conversions, both kinds of conversions, A, lossless, and B, are they fully automatable? So can you actually take the ancient Greek and Latin dependency tree bank, take some of their text and transform it to universal dependencies format with no manual intervention and reversibly, losslessly? And the reason for this question, I'll take that silly slide down. But the reason for the question is to sort of ask whether something like universal dependencies is just creating another format to add to the proliferation of formats, or is it actually something which the people who are still doing work in AGLDT or in S or various other things are potentially contributing to the universal dependencies Treebank already, and vice versa. If someone were to put some Greek and Latin in universal dependencies directly, would that potentially be useful to the people who are collecting Treebanks like Perseus and various other places? If that's not too many parts to one question.
Yeah, this is of course an extremely important question. I will soon leave the word to Marco, but as for my part, I'd like to say that that this conversion, this XSLT style sheet that transforms the ALDT to PML, it's completely lossless, so no information is lost. And of course, it could be automated, but there should be, I think there should be a project or an interested party that would do that automating. So please, Marco.
Well, the idea of universal dependencies is not to replace the currently available annotation styles for Treebanks, but it's more a way to complement them. I mean, for instance, I built the Index Domesticus Treebank for Latin. And the Index Domesticus Treebank for Latin, like the ancient Greek and Latin dependency Treebank, and like Proyal, talking about ancient languages, is available in both annotation styles. So in the original one and in the universal dependencies one. To me, this is a good idea, because different annotation styles tend to highlight different phenomena at different granularity of annotation. So it's always difficult to answer a question like, is it lossless or not? It depends on the annotation style you are moving from to universal dependencies. Because if you are moving from a very high granularity annotation style, most likely you will lose something moving to universal dependencies. Because universal dependencies want to be something general but not trivial, common but not imposing a standard that destroys the language-specific aspects. So in the case of the Index Domesticus Treebank and also the ancient Greek and Latin dependency Treebank, there is no loss, indeed, of information. There is a different representation of the same phenomena. And theoretically speaking, I like more the original Prague dependency Treebank style of annotation, which is the original also of the Prague dependency Treebank, ancient Greek Latin dependency Treebank. But this is more a theoretical approach. But the universal dependencies is fully motivated in an interlinguistic style. So I understand that if I wanted to remain closely and only related to the original style of the Index Domesticus Treebank, the Index Domesticus Treebank finally would have spoken just with itself, or with languages similar to Latin in terms of typological aspects. Instead, universal dependencies is really something that you can complement your Treebank with in order to make your Treebank speak with all the world. So it's not another standard. It's more an Esperanto. It's more a common language spoken by different Treebankers, And okay, I can speak English with you, but then I can speak Italian coming back to my house tonight with my girlfriend. And this is like in Treebank. Universal dependency is English now, and it's not well spoken by myself. And instead, I speak very well Italian, and this is the Index Domesticus Treebank original style. This does not mean that the Index Domesticus Treebank includes mistakes. Well, includes mistakes, indeed, but not so many, hopefully, even in universal dependencies.
Right, and so people working in both formats, someone who's working primarily in universal dependency, someone else who's working in Perseus, we're all, in the end, contributing to, potentially at least, to the same body of Treebank data that can be taken and put together by other people and used. Then they're not silos that will never speak to each other. And
you can always enhance the dependency relations of universal dependencies with language-specific relations. So you have a universal dependency relation and a language-specific universal dependency relation. So this helps to find a balance between these two levels. There is one level which is general and common and universal, and you have to address that. And there is a language-specific level.
Right. Thank you.
Just one more thing. Most of the Treebanks were built before universal dependencies was there, and so most of the Treebanks were not built in universal dependencies for scratch. So there are several conversion, not tools, conversion processes available. Usually people make the process available to the community, and instead now some new Treebanks already start from scratch using universal dependencies. And it's a good idea, because if I build a Treebank for a new language, I mean a language with no Treebanks, or for a specific domain of an already available language, I wanted my Treebank speaks with the others. So using universal dependencies is a good idea, which does not mean that you cannot use something else together with universal dependencies.
Great, thank you very much.
You're welcome.
I have a couple of other questions, but I want to let other people have an opportunity to jump in. Does anyone else have anything they wanted to ask or say or add?
Well, I could have continued a little bit with this that was just mentioned, but yeah, thank you both. These were really, really good presentations, and thanks, Marco, for giving this universal dependencies also this nice idea of Esperanto. So you said that yeah, there are many different ways to transform tree banks and so on. I was wondering just a little bit about if I'm annotating Greek and Latin, then I will of course want to use the annotation styles of ancient Greek and Latin dependency tree bank because I want these things to talk together. But then the universal dependencies have a slightly different way of doing things in several aspects. What I noticed. So, for example, how difficult was it to transform the index Domesticus to universal dependencies in terms of those things that are missing in ancient Greek and Latin dependency tree bank system? Like one example was maybe the direct object marking that is not there in. We only have the object for both direct and indirect objects, and that was used in universal dependency guidelines, I think. So,
well,
that should be added to the if you are transforming. So, how do you deal with that?
So, actually, if I'm not wrong, the object that is not used anymore in this version number 2 of the guidelines, but I have to check because I don't remember. But apart from this, what we used in this case and what was very helpful for us was were the morphological features. So we used morphological features first, and then we used also, yes, I'm right, there is no anymore the object that well. There is also, there is only the object that well, and then there is an I object that well. Anyway, your question is right. And so we used morphological features, and we used also the presence of some preposition in prepositional phrases, because following the PDT style, the movement complements, like I move this from here to there, from here and to there, are two prepositional phrases which are annotated as object in the Index Domesticus Treebank and in the Ancient Greek and Latin Dependency Treebank style, and also in PDT. So you have three objects there. I move this one from here, here two, to there, three, which is the object, which is the obl, so the oblique argument. This is clearly explained by the fact that there are two prepositional phrases, and these are the obl ones, while the object is the accusative one. So this was pretty helpful, and there is one paper which is published in the proceedings of the last Universal Dependencies workshop that was held on November 1st, if I'm not wrong, in Brussels. And there is a paper about the treatment in the conversion of specific phenomena in the Index Domesticus Treebank. It's online.
Okay, thank you.
Anyone else had any questions or comments to add? I'll ask another fairly brief question. Like, is it maybe there's a simple and quick answer to this. So, is it given that a tree bank is an expression of your interpretation of the grammar of the syntax, etc., of a sentence? And we've seen examples where two people might annotate the same sentence slightly differently because they've interpreted it differently. Doesn't that kind of suggest that the tree you end up with in your tree bank is kind of arbitrary? That potentially there's all sorts of other possibilities, that the one you've ended up with is just randomly selected.
Timo.
Yes, of course. That's obvious that there is lots of ambiguity due to arbitrariness of individual decisions and individual interpretations of all possible guidelines, and I think that's something that can't be overcome at the end, and there won't be any faultless, perfect tree bank. They will always contain problematic passages, errors, and many of those remain unnoticed, because when you write queries, you only find those occurrences that are there marked with the same stencil you have designed, but you don't find those that are misannotated, that are annotated in a deviant way, and that of course influences all the results, and that's something that it would be interesting to examine how much there is this kind of how much there are this kind of errors that don't show up when you are writing queries, but of course that would need an individual to do the examination, and it would be also an evaluation of the quality of a given tree bank.
I fully agree. The answer is of course. And in my experience, most of the different annotations provided by different annotators, let's say with the same experience, because experience is very important in this task, result from either a misunderstanding of the guidelines, and so there is a mistake there. It's an error, according to the guidelines. And these must make think that the guidelines are not clear on that point. Second, errors differences coming from an under-specification of the guidelines on one specific construction. And this is another point. While the lowest number of differences are genuine different interpretations of the same passage, which is sometimes the case, especially when you deal with an ancient language. You don't have native speakers. You cannot call Cicero and ask him, what do you think about this construction of this sentence that you wrote? And so it's my word against Timo's word. And sometimes more than one interpretation is possible, because life is like this. Sometimes it's possible. You can understand in different ways and interpret in different ways the same passage. And philologists has passed the last centuries on some of these aspects. And it's nice that Treebanks are there to represent this. So one challenge in the field is to provide parallel annotations which represent parallel genuine interpretations and not errors of the same sentence and passage, which is something that we haven't yet. We have one representation in the Treebank, but sometimes it's not like this. And this is something that every day occurs to me when I check the annotations of my best annotator. And sometimes I think, well, she is right, but I think something different. And finally, my interpretation is there in the Treebank just because I'm the head of the project. Well, it's a criterion. Well, most likely it's not the most democratic criterion, but that's it. So we will find a way to have both interpretation, one from the coordinator of the project and one from a very experienced annotator.
Yeah. Thank you. Did anyone else want to comment on that question? If not, I have another question. The next question is from somebody who was surprised to come across tree banking. And the question was, I thought from having studied linguistics that trees were considered a long outmoded way of describing language. Any reactions?
I think this is Marco has to answer this, because I'm a very pragmatic person, and I'm not interested if these are out of fashion or not, and at least they are practical, even though they might not be theoretically the most reasonable choice. I can use them because I can handle them.
Well, I think that this person had in mind phrase structure grammar. Well, this is a bit provocative, but I mean that it's true that in theoretical and general linguistics, the Chomskyan style trees seem to be a bit old-fashioned. Well, there is a long story here about theoretical linguistics in the 20th century, but it's interesting to see that the elements of structural syntax, which is the basic book by Lucien Tenière of dependency grammar, and syntactic structures of Chomsky were published in the same time, 1957, 1959. But the Chomskyan book had a huge success, really ruled the linguistic world until the 90s, more or less. Then it became a bit old-fashioned, so maybe we were talking about those trees. No one was using dependency grammar. But suddenly, we realized that English is not the only language. And we started to build tree banks for different languages, with typologically different, showing a different word order, dependency grammar, and the poor Lucien Tenière finally won the battle and became a very suitable tool for this very new need, building a bunch of empirical evidence annotated with syntactic analysis. And so I would say that exactly the opposite of what this person said. Yes, Chomsky trees are pretty out of fashion now, but dependency trees are the state of the art.
Great, thank you. Cool. Are there any other questions or contributions from anyone else in the group? If not, then it is about 1:15, so I guess we're technically at the end of our slot. So I guess I thank Marco and Timo again. And please join us again next week for the first of 2 sessions where we'll be introducing programming language. We'll be introducing R next week. And just as a sneak preview for that, 2 weeks after that, the second session on R, one of the case studies using R will be using R to examine tree banks. So if you haven't had enough of tree banks yet, then you can't miss the introduction to R, otherwise you won't be able to follow the third one. So thank you very much. See you next week.
Okay.
Cheers.
Bye.